Hi guys, Maing Adlaw. Welcome back to my channel. But if you are new to this channel, please do not forget to subscribe and click that notification bell so that you will be notified for future uploads. So for today's video, I will be presenting to you about solving systems of linear equations in two variables. There are three ways in solving systems of linear equation in two variables. Number one is by substitution. Number two is by elimination. Number three is by comparison. We will focus by substitution method for this video. We will have a separate video for elimination and comparison. So to start, let us have the lesson objective first. At the end of this video, you should be able to solve systems of linear equations in two variables by substitution method. Okay? So let us proceed to our examples. For example, we are given this set of equation. X minus 3y equals negative 12 for equation 1 and 4x plus 6y equals negative 12 for equation 2. So as you can see, we have these variables x and y. So our focus here is to solve for the values of x and y so that we'll make the equation a balanced equation, or the values of x and y that will make these two equations a true statement. So first things first is to decide which variable we are going to solve first. But you have to analyze the given which of these two equations is much easier for us to manipulate. So if we are going to analyze, we will have equation 1, x minus 3y equals negative 12, which is much easier to manipulate than equation 2. Why? Because we have here x in equation 1, which has 1 as the numerical coefficient. So it would be easy for us to manipulate this equation by just simply using addition property of equality to eliminate the y at the left side of the equation. We are going to manipulate equation 1 so we can have, this is x minus 3y equals negative 12. So for us to eliminate this negative 3y here, so we need to add 3y so that we can cancel this out. And of course, since we added 3y at the left side of the equation, we will also add 3y at the right side of the equation. That is by addition property of equality. So in this case, we can cancel out the 3y. So this will be cancelled out, or that is 0. So what remains at the left side of the equation shall be the x. And of course, this is now your equation. The purpose here is that we will be substituting this initial value of x in terms of y to equation 2. That is to solve for the value of y. We will substitute this initial value to equation 2 because this is taken from equation 1. So to proceed, to solve for y, our initial value for x in terms of y is negative 12 plus 3y. So by substitution, we substitute, instead of writing x here, we substitute the initial value of x in the first equation. So we just simply copy 4, then we change x with the initial value of x from the first equation, which is negative 12 plus 3y. Then we just simply copy 6y and copy equals negative 12. This time we simplify. We distribute 4 to the terms inside the parentheses. So that gives us 4 times negative 12 is negative 48. 4 times positive 3y is positive 12y. Then we copy 6y equals negative 12. The next is to combine like terms. We have 12y plus 6y. So that would give us positive 18y. So what we did with negative 48 is we just simply copy negative 48. Now to eliminate negative 48 at the left side of the equation, we will use addition property of equality because this is negative. So if we are going to use addition property of equality at the left side of the equation, so we will add 48 here. Of course, we will also add 48 at the right side. In this case, we can cancel out negative 48 plus 48. So what shall remain at the left side of the equation shall be 18y equals negative 12 plus 48. As I've said, we added 48 here. We will also add 48 here. So the 48 here will be cancelled out, but we will have the 48 at the right side of the equation. So negative 12 plus 48 is equal to positive 36. And again, the operation between 18 and y is multiplication. So to eliminate 18, because we are only going to solve for the value of y. So to eliminate 18, we use division property of equality. We divide both sides of the equation by using division property of equality. Divide both sides of the equation by 18. In this case, we have the 18 here and 18, so we can cancel out the 18. So what shall remain at the left side shall be y. Then 36 divided by 18 is 2. So therefore, for this set of equation, our y is equal to 2. Now, since we already have the value of y, which is positive 2, we can now substitute this value to any of these two given equations. Okay? We can use equation 1 or equation 2. For this example, we will be using equation 2. That is 4x plus 6y equals negative 12. Now, since we already have the value of y, which is 2, so we will substitute this one to y here. So that becomes, we copy 4x, we copy plus, we copy 6, and instead of writing y, we change that with the value of y, which is positive 2 here. Then we copy equals negative 12. Then 6 times 2 is positive 12 equals negative 12. Then copy 4x. Again, since we have the positive 12 here, we will use subtraction property of equality. So we will subtract 12 here. We cancel out. Then we subtract 12 at the left side. Since 12 is cancelled out, so what remains here is 4x, and we have subtracted 12. So negative 12 minus 12 is negative 24. So to solve for x, we need to divide both sides of the equation by 4. We also have to divide here by 4. So we cancel out the 4, then what shall remain at the left side shall be x equals negative 24 divided by 4 is negative 6. Okay, so therefore, for this set of equation, the values that will make these two equations a true statement are y should be equal to 2 and x should be equal to negative 6. Now, to check if these values are correct, we have to go back to our equation. So these are the set of equation. Then our values, we have x equals negative 6 and y equals 2. So we will check for equation 1 first if these values will really give us a true statement for this equation. So now we substitute these values to this equation. So our x is negative 6. So instead of writing x here, we will change that with negative 6. Then we copy minus 3. Then instead of writing y here, we multiply that with 2. So this would become the x, which is negative 6, minus the 3, the y is positive 2. Negative 3 times 2 is negative 6. Then negative 6 minus 6 is of course negative 12. So therefore, the values gives us a balanced equation. Okay, how about for equation 2? Let's try to check if these values will still give us a balanced equation for equation 2. So the same, we substitute. We have 4, we copy the 4, the value of x, which is negative 6, plus the 6 here, and the value of y is positive 2. Then we simplify. 4 times negative 6 is negative 24, and 6 times 2 is positive 12. Negative 24 plus 12 is, of course, will give us negative 12 is equal to negative 12. So therefore, since these values gives us a balanced equation for both equations, so therefore, the values are correct. Okay, let's proceed to the second example. How about we are given this set of equation? Y equals negative 4x plus 16 for the first equation, and the second equation is negative 3x plus 3y equals 23. We have equation 1, which is y equals negative 4x plus 16, which is now already the initial value of y in terms of x. So there is no need for us to find for the initial value of y because we already have the initial value of y in equation 1. We just use this value to substitute in our y for the second equation. So therefore, this will become, to solve for x, we have the second equation, which is negative 3x plus 8y equals 23. So we will substitute, this is our y, initial value is negative 4x plus 16. So we have negative 3x, this one we copy negative 3x, plus we copy the 8, Then instead of writing the y here, we will substitute the initial value of y in terms of x, which is negative 4x plus 16. So what we did here for this equation, we just simply substitute the initial value of y in the first equation to y in the second equation. So this one. We multiply the 8 here to the terms inside the parentheses. We simplify. So we copy negative 3x. This one we copy here. Then positive 8 times negative 4x, that would give us negative 32x. Then positive 8 times positive 16, that's positive 128. Then equals 23. Then combine like terms, we have negative 3x minus 32x. That would give us negative 35x. Then we copy positive 128. Since this is constant and we only need the variable x at the left side of the equation, so this is positive, we need to subtract 128 at the left side. Of course, we also need to subtract 128 at the right side. That is subtraction property of equality. In that case, we can cancel out the 128 here and we have 23 minus 128. So 23 minus 128, that would give us negative 105. Then we have negative 35 as the coefficient of x. So to eliminate the negative 35, of course, we divide both sides of the equation by negative 35. Of course, divide here by negative 35. So we can cancel out the 35, and what shall remain at the left side shall be the x, and negative 105 divided by negative 35, that would give us positive 3. So for this set of equation, our x is equal to positive 3. This time, to solve for the value of y, we go back to any of these two equations to solve for the value of y. So we can choose from equation 1 or equation 2 to solve for the value of y. But for this example, we will be using equation 1 to solve for y. So since our x is 3, so we will substitute this value to x here. We copy negative 4 times the x is 3, so we have the 3 here, then we copy plus 16. Then negative 4 times 3 is negative 12, then plus 16, that would give us positive 4. So therefore, our x is positive 3, our y is positive 4 for this set of equation. These values will give us a true statement for both equations. So to check, let us go back to the original equations. And these values, x equals positive 3 and y equals positive 4. So to check, for equation 1, we have y equals negative 4x plus 16. Our y is 4, so we change y here by 4, and of course, we change x here by 3. So this becomes 4 equals negative 4 times the 3, which is 4x, plus the 16. Negative 4 times 3 is negative 12. Then we copy positive 16. And of course, negative 12 plus 16 is 4. So that is 4 equals 4. So we got a balanced equation for equation 1. Let's do the same for equation 2. That is negative 3x plus 18y equals 23. So we substitute. We have negative 3 times the x is 3. We have positive 8 times the y is 4. Then we multiply. Negative 3 times 3 is negative 9. And 8 times 4 is positive 32, which is equal to 23. Then 9 plus 32 is of course 23 is equal to 23. Okay, so let's proceed to third example. This is now our last example. So example number 3. We are given this set of equation x minus 3y equals 2 and the second equation 2x plus y equals 11. So in this equation, it would be easy for us to manipulate equation 1, but actually we can also manipulate equation 2. It's up to us which equation that is we are comfortable of manipulating so that we can solve for the initial value of a given variable. For this example, we will use equation 2. In this case, we have 2x plus y equals 11. We have the 2x here, which is this one. We will subtract 2x so that we can cancel this out since we subtracted 2x at the left side, we will also subtract 2x at the right side. That is by subtraction property of equality. So in this case, we can cancel out the 2x. So what shall remain shall be y equals, we have 11 minus 2x. So 11 minus 2x, this is now the initial value of y in terms of x. This is taken from equation 2. And since this is taken from equation 2, we will substitute this one to equation 1. So, to solve for x, our equation 1 is x minus 3y equals 2. So, we substitute, we copy x, we copy negative 3, and instead of writing y, we change that with the initial value of y in terms of x from equation 2, which is 11 minus 2x, then we copy equals 2, this 1. Then we simplify, we distribute negative 3 to the terms inside the parentheses. So we copy x, negative 3 times 11, that would give us negative 33. Then negative 3 times negative 2x, that would give us positive 6x. Then equals 2. Then we combine like terms. We have the x here plus the 6x, so that would give us 7x. Then, since we have the constant negative 33 here, to cancel this out, we add 33. Of course, we will also add 33 at the right side. So 2 plus 33 is, of course, 35. Then divide both sides by 7. So cancel out 7. What shall remain is x equals 35 divided by 7 is 5. So therefore, our value is 5. Now, to solve for y, we go back to these equations. We choose from these two equations to solve for y. For this example, we will choose equation 1. Okay, so equation 1 is x minus 3y equals 2. So our x is 5. We substitute 5 instead of writing x. Then we copy negative 3y. We copy equals 2. Since we are going to solve for y, we will use subtraction property here. So we will subtract 5 here. To cancel this out, of course, we will also subtract 5 at the right side. Then we need to divide both sides by negative 3. That is cancelled out. The 3 is cancelled out. So what shall remain at the left side shall be y, and negative 3 divided by negative 3 is positive 1. So our values are x equals positive 5 and y equals positive 1. Let's go back to our original equation. So we will check, these are the values, x equals 5 and y equals 1. So we will check equation 1, x minus 3y equals 2. Substitute, x is 5 and y is 1. So 5 minus 3 times 1 equals 2. That would give us 3 times, negative 3 times 1 is negative 3. 5 minus 3 is positive 2. So that is 2 equals 2. For equation 2, we will have 2x plus y equals 11. So that gives us 2 times the x is 5 and the y is 1. So 2 times 5 is 10 plus 1 equals 11. So that is 11 equals 11. So we got a balanced equation for equations 1 and 2. So therefore the values are correct. Okay, that's it. I hope you have learned something from this video. And next video will be about solving systems of linear equation in two variables by elimination and by another video for comparison. And of course, I still have to continue doing videos about general mathematics. So watch out for my videos for general mathematics.